Hello everyone, I am Dr. Imran Chandarki, working as an assistant professor and dean PG program at the Department of General Science and Engineering and NB Navale Sehan College of Engineering, Solapur. I have total teaching experience of 15 years and research experience of around 7 years. I did my PhD in mathematics from Dr. Baba Saheb Ambedkar Technological University, Loanere in the year 2014, and I have been now recognized as a PhD guide in mathematics at Punna Shlok Hailabari Holka Solapur Institute, Solapur. My area of specialization is applied mathematics, numerical methods, boundary theory. I have written 6 books and published more than 21 paper at journals and conferences of international repute. Now, in continuation with multiple integration, I am going to talk on a new bit that is called change to polar form. Just now we have finished the problem based on why to change and how to change the problems of double integration to change of order case. Now we are going to see why and how to change the problem to polars. Now in what case we should convert our problem to polar. Now see, if your region of integration is bounded by circular curves, or your integrand involves a function of x square plus y square. Okay, so if it is a completed function of x square plus y square, yes, it is reasonable to convert the problem, that is double integration, to which form? Polar form. Now you know that in Cartesian double integration we had two strips, that is a strip parallel to x-axis and strip parallel to y-axis. And what the strip parallel to x-axis, that is horizontal strip, will move from bottom to top, whereas a strip parallel to y-axis, that is vertical strip, will move what from left to right. Okay, but here in polar coordinate system you will be having a radial strip. So see, this is the radial strip, it is starting with origin. Okay, actual strip is this dotted line. Okay, so this is the extended part of this radial strip, and this radial strip will rotate. Okay, so you will be having a radial strip like this. So this radial strip will rotate. Okay, so from what? From this, that is theta equal to alpha to theta is equal to beta. Okay, note that while its rotation, now I am not going to move, I am going to rotate it. So it is rotating from theta equal to alpha value to theta equal to beta. That's why the upper limit value will be from alpha to beta. Okay, while its motion, you can check it out that the lower end, where is the lower end? Lower end is on the first curve. What is the first curve? R equal to h1 of theta. So what lower end is on? R is equal to h1 of theta, whereas you can check it out the upper end of the strip, or that is outer end of the strip. So inner strip and that is outer strip. So inner strip of this strip is on R is equal to h1 of theta, and outer strip of the outer end of the strip lies on what? R equal to h2 of theta. That's why limit of this region, limit over this region R in polar coordinate system will be given by integration from what? Alpha to beta. So it moves from alpha to beta, it rotates from alpha to beta. Inner end is on what? H1 of theta, and outer end is on h2 of theta throughout this region. And that's why, yes, limit will be from alpha to beta and h1 of theta to h2 of theta. Okay, and in the integrand, if you have x term, replace it by what? X equal to r cos theta, y by r sin theta, and if you have what? X square plus y square, replace it by r square. And if what? That is very important, if you have dx dy, then replace it by r dr d theta. Okay, so using Jacobian concept we have obtained what? Conversion of dx dy to r dr d theta. So dx dy is what? R dr d theta. Okay, so do that simplification and adjustment, and try to convert your polar coordinate system to Cartesian coordinate system to polar. Okay, you will find that the integration in Cartesian form, some of the integration in Cartesian form are what? Unevaluable with given order of integration. Even if we change the order of integration, some of the integration you will find that they are still difficult for its evaluation. But once you change the problem to polar form, what? They will become very convenient for evaluation. That's why we change the order. Okay, so change the problem to polar form. So what is the procedure for changing to polar form? First of all, you see what is region of integration. In region of integration, yes, you take a radial strip. Radial strip, it starts with origin, okay, and it ends with outermost curve. So this is the outermost curve. Okay, and that stream rotates in anti-clockwise direction. So from theta equal to alpha to theta equal to beta, because that is the range of your region R. Okay, while its motion you see where is inner end and where is outer end, that is gives you limit of inner integration limit. So this one is outer integration limit and this one is inner integration limit. Okay, and if you have x, put that equal to r cos theta, y equal to r sin theta, and if you see what x square plus y square term, replace it by r square, that is under root of x square plus y square is equal to r. Let us have first problem. So here is the first problem. Here is the first problem. Yes, the problem is change to polar and change to polar coordinate and evaluate. Okay. So let us see how to change the problem to polar and evaluation. Now the region of integration here will be bounded by 4 curves. Here the region of integration is bounded by 4 curves. Okay, the first curve is what, as inner integration limit is in terms of y, therefore it will be limit of which variable, x, and you can see that outer integration limit obviously will be limit for y variable. Okay, so x, what the four curves which will bound region of integration are what, x is equal to y. Okay, x is equal to 1 plus under root of 1 minus y square. Okay, the next curve is y is equal to 0, y is equal to 1. So next two curves are y is equal to 0 and y is equal to 1. Okay, now I think the most complicated curve is x equal to 1 plus under root of 1 minus y square. Let us recognize what this curve is. So for that, let me take this x on that side. So it becomes what? So this curve becomes x minus 1 is equal to what, under root of 1 minus y square. Squaring, we get what, x minus 1 bracket square is equal to 1 minus y square. Taking minus y square on that side, we get what, x minus 1 bracket square plus y square, and y square can be written as y minus 0 bracket square is equal to 1. Okay, so what this is, so is it looking like x minus a bracket square plus y minus b bracket square is equal to r square. So here what this is, so it is a standard circle, okay, having center at AB and radius equal to r. Okay, this, so this also is a circle, x minus 1 bracket square y minus 0 bracket square equal to 1. 1 can be written as 1 square. So this also is a circle, and this circle is having center at 1 0 and radius equal to 1. So let us draw a circle with center at 1 0, radius equal to 1. Okay, so what you will be having your x-axis, so you will be having your x-axis, so this one is your x-axis, this one is your y-axis. Okay, then directly I am going to draw this circle. This circle is having center at what, so center is at what, 1 0, center is at 1 0. Note that if this is 1 0, obviously this will be 2 0, because that will be a what, diameter. This is the radius, radius is 1, diameter will be 2, so this will be 2 0. Okay, so draw a circle. So let us draw a circle of radius what, so let us draw a circle of radius, okay, of radius 2. So this is a circle of radius 2, or otherwise let us sketch it. So this is the circle of radius, this is a circle of radius, okay. So this is your circle of radius, hmm. So this one is your circle of radius 1 and center at 1 0. Okay, so that is your first curve. Now what about second curve? Second curve is x equal to y. Obviously it is a very standard curve. X equal to y is this. Okay, it is a straight line bisecting first and third quadrant. Okay, so it is a straight line bisecting first and third quadrant. Okay, then the next curve, what next curve is y is equal to 0. Okay, so obviously y equal to 0 will be here. Okay, and last curve will be y is equal to 1. Note that what this will be the point of contact. If you put what x is equal to 1, okay, y also will be equal to 1. And if you solve these two, so if you put what y is equal to x here, what we get, x square plus x square, that is becoming 2x square is equal to 2x, and that gives you x equal to 2. Okay, so you'll find that the point of contact will be x is equal to 1, y also is equal to 1. Okay, so you'll be getting one of the value equal to 1, 2 will get cancelled, x is equal to 1. Okay, so you can check it out. So we get what, 2. So put x equal to, put what, y is equal to x, and what we get, y is equal to x. So we get 2 x square plus x square is 2x square. So this is x square, this is also x square plus x square is 2x square is equal to 2x. And you'll find that what, 1 2 will get cancelled, 1x will get cancelled, leaving you what, x is equal to 1. Okay, so x is equal to 1, and if you put x equal to 1, y also will be 1. Therefore this point of contact will be 1 1. So if x is 1, y is 1, and that's why y equal to 1 will be acting as a tangent, and it is even what, bisecting with your x equal to y. And from that what you will find that what the fourth curve, y equal to 1, is tangent. Okay, so let us have that curve also. So y is equal to 1. So your region of integration will be between two parallel lines. Which lines? What, your y equal to 0 and y equal to 1. So if your region is here, let us recognize it. How to recognize? There are so many options before you. Okay, it may be region number 1, region number 2, region number 3, region number 4, and so on like that. There are so many regions here, region number 5 even. So you can have any one region as region of what, integration. Now how to guess what is the region of integration? So for that, let me have once again a strip parallel to x-axis. This strip moves from bottom to top. Okay, so this strip moves from bottom to top, starting with y is equal to 0, ending with y equal to 1. While its motion, left end, where is the left end? Left end is on x equal to y, and right end is on what? Right end is on, yes, which what, that is very important. Okay, that's why I need to discuss it. So right end is on, where is right end? So left end is on y equal to x. Okay, you can check it out. Left end, that is left end is here, left end is on x equal to y, and right end is on x equal to 1 plus under root of. So what is x equal to 1 plus? 1 plus will be a circle, part of circle after it. So you can see 1 is here, so x equal to 1 plus something. So 1 plus something will be this part of circle. Okay, if it could be 1 minus, then I would have taken this part of circle. So what we are dealing with, which part of circle? This part of circle. Okay, because it is what, x equal to 1 plus. So left end is what, here, and right end is here. Therefore it will swept out region number 3, this region number 3, and that's why we have shaded it. Now it is not a problem of what, changing the order. Okay, it is a problem of changing to what, polar coordinate system. And that's why if we want to change the order, yes, what I will do, I will take a radial strip. Okay, so this is the radial strip, and this radial strip okay, will move from what, will rotate from what, the starting region is here, and equation of this line is theta equal to 0 in polar coordinate system. That's why theta varies from 0 to this point. And note that x equal to I is a line bisecting first and third quadrant, means what, bisecting 90 means it is 45 degree. So it moves from theta equal to 0 degree to theta equal to 45 degree. While this motion, you can check it out, what inner end is on theta r equal to 0, and outer end is on what, the circle. Now let us convert this circle in terms of r. Okay, so this circle is what, nothing but x square plus y square equal to 2x. Okay, so if you put x square plus y square equal to r square, what we get? We get r square equal to what, 2r cos theta. So one r will get cancelled, r is equal to 2 cos theta. So this is nothing but what, r is equal to 2 cos theta. Okay, so inner end is on what, so your ends of the strip are here. Okay, upper end is here, lower end is here. Okay, so while its motion starting with theta equal to 0, so theta varies from 0 to pi by 4. Okay, and r varies from, so inner end of the strip is on r equal to 0, that is pole. Okay, r equal to 0 is pole, and what, outer end of the strip is on r is equal to 2 cos theta. Okay, note that r equal to 2 cos theta is equation of circle. Okay, having center at what, 2 divided by 2, that is 1. Okay, so 1 0 and radius equal to 1. Okay, so what limit is this? Okay, so if you substitute all of the stuff here in this double integration, so double integration over the region r, so what is limit? 0 to pi by 4 and 0 to 2 cos theta. Yes, so we have substituted what, x square plus y square equal to r square. So in this integrand, yes, in this integrand, x square plus y square, this stuff is r square. So r square, so 4 plus r square bracket square, and dx dy is r dr d theta. So what we have this type of integration now. So 0 to pi by 4, 0 to 2 cos theta, r dr d theta divided by 4 plus r square bracket square. Now first integration is to be carried out with respect to r. So if we are integrating with respect to r, theta should be kept outside. Why we are integrating with respect to r? Because innermost integration is what, in terms of theta it will be limit of r. So let us integrate with respect to r by keeping theta outside. There is only one term of theta, that is d theta, can be kept outside inner integration, but it will be inside outer integration. So by putting 4 plus r square equal to t, we can very easily integrate this term, and integration will be like this. We get the answer equal to this minus 1 by 8 and 1 upon under root of tan inverse of 1 by root 2 minus r by 4.